Hi everyone. Today we're going to be focusing on solving quadratic equations by factoring where a equals 1 or if there's special cases. Yesterday you took a look at factoring in general and took a look at some special cases. The two important ones that we focused on was the difference of perfect squares and perfect square trinomials. Today we're going to be using those factoring methods in order to solve quadratic equations. Now, when you're solving quadratic equations, the first thing that you have to make sure to remember is that you have to set your equation equal to 0 before factoring. If you forget to do this, the equation is most likely not going to be factorable and you're not going to get the correct answer. So in order to do that, you want to move everything to one side of the equal sign. And what I usually choose to do is make it so our quadratic term, the coefficient, is positive. So that way it makes it a little bit easier in order to factor. Then after we set it equal to 0, we determine how we're going to factor this equation, either by using normal factoring methods or one of the special cases like difference of perfect squares or perfect square trinomials. After that, we're going to factor and use the zero product property in order to solve for the variables. All right, so let's take a look at number 1. First thing we have to do here is set it equal to 0 by adding 2r to both sides. So we have r squared plus 2r minus 24 is equal to 0. And what we notice is this doesn't look like a difference of perfect squares or perfect square trinomials. So we want to find two numbers that multiply to negative 24 that add to positive 2. That's going to be positive 6 and negative 4. So we'll write that as r plus 6 times r minus 4 is equal to 0. Now using the zero product property, we're going to set both of these binomials equal to 0. So we have r plus 6 is equal to 0 and r minus 4 is equal to 0. Then we solve for r, so we get r is equal to negative 6 and positive 4. And those are our two solutions. All right, let's take a look at number 2. For number 2, what we notice is that we have a coefficient of x squared that's negative 4. Again, like I said earlier, we want our coefficient of x squared to be positive, so I'm going to move the 4x squared and the negative 20x over to the left side to set my equation equal to 0. So I have 4x squared plus 20x minus 56 is equal to 0. Now, I know today we said that we were going to focus only on factoring when a equals 1. This one actually is a case where a equals 1. However, we have a GCF, so we have to recognize the GCF first, factor that out, and then we'll have a quadratic equation where the a value is 1. So what we're going to do is factor out of 4, because we have a common factor of 4 with all the terms. We have x squared plus 5x minus 56 divided by 4 is 14. It's equal to 0. So now we're going to forget about the 4 for right now. And we're going to factor the quadratic expression inside the parentheses first. So we're looking for two numbers that multiply to negative 14 that add to 5. It's going to be positive 7 and negative 2. So we'll have 4 times x plus 7 times x minus 2 is equal to 0. Now using the zero product property, we get 4 equals 0, x plus 7 equals 0, and x minus 2 equals 0. Now, something weird that happens anytime you're factoring and you have a GCF like we did here is you'll notice that we had to say that 4 equals 0 because if either 4, x plus 7, or x minus 2 is equal to 0, that'll satisfy this equation. So what you notice is you get something weird right here that 4 equals 0, which doesn't make sense. So we can just cross that out. So we have x plus 7 is equal to 0 and x minus 2 equals 0. So we get that x is equal to negative 7 and positive 2. All right, moving on to number 3. So here we notice that we have a quadratic equation. However, there's no linear term. So we have two options on what to do here. We can either continue to solve by factoring, or we can use square roots that we talked about earlier this year. Now, for our purposes today, we're focusing on factoring, so I'm going to follow those steps. If you recognize that you could use square roots, then go for it. You're more than welcome to do that. So in order to solve this by factoring, what I need to do is subtract 18 from both sides. So I have 2x squared minus 18 is equal to 0. Now what I want to do is look for a GCF, which is a 2. So we have x squared minus 9 is equal to 0. And you might be thinking, hopefully you noticed that x squared minus 9 is the difference of perfect squares. If you didn't, you could also factor this using normal factoring methods. Because our a value is 1, you're looking for two numbers that multiply to -9 and add to 0, which is where we get the plus or minus 3. So this is going to factor to be 2 times x plus 3 times x minus 3 is equal to 0. So we get that x is equal to -3 and +3, or if you'd rather write that as plus or minus 3, that's totally fine as well. All right, number 4. Again, our coefficient of the x squared term is negative, so I'm going to move everything to the left side of the equal sign. So I have x squared plus 14x plus 49 is equal to 0. Now, hopefully you're starting to recognize that this would be a perfect square trinomial. So two numbers that we would find that multiply to 49 that add to 14 are +7 and +7. So we can jump right into x plus 7 squared is equal to 0. But if you didn't know that, you could use traditional factoring methods looking for two numbers that multiply to 49 that add to 14, and you would arrive at the same answer. So this would factor to be x plus 7 squared is equal to 0. We take the square root, we get x plus 7 is still equal to 0, and we get that x is equal to -7. So when you have a perfect square trinomial like this one in number 4, you're only going to get one solution. All right, moving on to our last example. So for this one, this is kind of combining perfect square trinomials with the GCF. So what we're going to have to do is move everything over to the left side. The reason I'm doing that is because my coefficient of p squared is +3. I want to keep that positive. So I have 3p squared minus 24p plus 48 is equal to 0. Now, what we need to do is look for a GCF, which in this case would be 3. So I'm going to factor that out. And I'm left with p squared minus 8p plus 16 is equal to 0. So what we notice is that our coefficient of p squared is now 1, so just like the previous examples. What you also might notice is that p squared minus 8p plus 16 is a perfect square trinomial. It's p minus 4 squared. So we can factor this to 3 times p minus 4 squared is equal to 0. Set both of these equal to 0 and solve. So we have 3 equals 0, and p minus 4 squared is equal to 0. Again, 3 equals 0 doesn't make sense, so cross that out. And we get p minus 4 equals 0, meaning that p is equal to +4. All right, that's everything today on solving by factoring where a equals 1 and the two special cases that you took a look at yesterday. Please make sure to do today's portion of the weekly assignment and keep an eye out for the week's Edulastic. Feel free to reach out if you have any questions or need any help. Have a great day, everyone.